This video is about mistakes that students usually do while finding Is or Vs using Laplace transforms. So the first step is to find the Laplace transform of the given circuit. So we will find the Laplace transform of each and every element present in the circuit. Suppose the given voltage source is DC voltage source. So while converting this into its Laplace transform, Laplace domain, first step is to convert, to find Laplace transform or Laplace domain as domain, that is as domain of the given time domain circuit. So first, this voltage source, if it is DC, it will be changed by V by S. Suppose it is 5 volts, so it will be changed by 5 by S. Okay, now this is called Vs. Vt will be changed to Vs and the value will be V by S. This resistance, there is no change. This current is now known as Is. Okay, this capacitor, it is transformed as a reactance of value 1 by Cs along with a voltage source with polarity plus minus in this direction of the source voltage, and its value is V0 minus divided by S. Okay, the capacitor is now changed into the combo of 1 by Cs reactance and V0 minus by S, and inductor is changed into a reactance of Ls along with the voltage source with from negative to positive. Okay, take care. This is positive to negative, same as direction of voltage source, and this is just opposite of it, and its value is Li0 minus. This I0 minus and V0 minus are the voltage and current across inductor and capacitor at time t is equals to 0 minus. So these two are our initial conditions. And this Ls and 1 by Cs is reactance. So this is not the voltage drop. So third thing that we have to take care of while applying KVL. When we will apply KVL across loop, here we will apply 2 times KVL because there are 2 loops. Suppose this is I1S and this is IS current. So this is not the voltage drop. When it is multiplied by this current, then it will become a voltage. This is just like an impedance. So we will start from any point. Suppose we are starting from this point. When if we are moving in the direction of current, plus minus, current always flows from higher to lower voltage. So minus sign will come. So minus I R into Is. This is capacitor will be charged like this. Plus upper plate from this positive terminal and lower plate negative from this negative terminal. So again we are moving from plus to minus. So we will take into mind the last sign. Our capacitor will be its impedance 1 by Cs multiplied by current Is. In this branch there are 2 currents. One of them is Is, another is I1S. So we have to consider both. Is is from plus to minus, but I1S is from minus to plus. So we will take its sign as plus, and in bracket it will become I1S as a minus. Okay, this is finally plus, but since we are writing it in bracket, so it is written as this. This is the voltage. This is nothing but the complete voltage. So we will again consider the last sign, that is minus V0 minus divided by S, and this voltage is plus. In last, this plus sign is there, comes in this voltage. There is a voltage rise. So we will take the plus sign, that is V by S. This is the way to write KVL equation. Start from any point, move along the loop, and if there is drop, then take negative sign. If there is drop, take negative sign. If there is a drop in voltage, or then take negative sign. If there is rise, then take positive sign and come to the same point from where we started. This is the way. And here in the common branch, we have to consider the two currents, first in this loop and second in this loop, and their direction will be according to the way they are moving. So these are few things that we should take care of. And the last but not the least, what is the if we are using a DC source, it's okay, it is V by S. But what about AC source? If there is an AC source, suppose there is a unit step function, signal is unit step sort of, then its Laplace will be 1 by S. If it is multiplied by T, if unit function is multiplied by T, then it will behave as a differentiator. Okay, this will differentiate this function. So here will come d by ds of this function, and d by ds of this function with negative sign. So this will come equal to 1 by s square. Okay, this is our ramp function. Now the third function is impulse function, and that is written as del t. Del t, its Laplace transform is always 1, and if it is written in time shifted mode like t minus c, then its transform will be e to the power minus cs. If it is written like this, then its Laplace transform will be e to the power minus cs. It is always with a unit step function. That is, if it is not written, then in hidden there is a unit step function. Okay, so this finally will come as e to the power minus cs by s. And next function, if a function it is multiplied by e to the power minus alpha t, then what will be changed? Because of this, the transform is 1 by s, and because of this alpha, there will come 1 upon s plus alpha along with this. Okay. These are few examples. If function is sine beta, then it will be, its Laplace will be s square plus beta square beta. Okay. If exponential minus alpha t is multiplied, then this s will be changed to s plus alpha only. This is the way to convert the any time domain to its Laplace. Thank you.